Hi everyone. Right, thanks for joining us this evening. Right, we have Hugo. Right, I keep pronouncing his name wrongly. So anyway, he's from the US. He's our senior principal developer advocate. So he will be talking to us on the event match for tonight. So feel free to ask any questions or stop us if you have any questions. Along the way. I'll hand it over to um, Hugo. Right.
Don't worry about that. Yeah, it's a common thing. So as you can notice by my name, even though I'm coming from the U.S., I'm not originally an American citizen. I'm just a Mexican. So that's why the pronunciation it's different in Spanish. So bear with me. A little bit of introduction. So yeah, the it's great to be here with you and being able to share some of the concepts that we are bringing from the application services business unit from Red Hat. I know that most of us know Red Hat from the platform perspective, but in 2006, Red Hat bought JBoss, and the application services, or what we used to call middleware in the past, was added to the Red Hat portfolio. And since then, we have been working around making the experience of building and developing applications and workloads on top of OpenShift and RHEL easier and better. In my case, I'm coming from the developer side, so I have been doing app development since 1996 when I started to write Java applets for HTML sites, very long time ago. And then I did some development using Visual Basic, and then Java, and then lately JavaScript. And 10 years ago now, I joined Red Hat as part of the sales engineer teams for middleware and application development. And 5 years ago, I changed from my local position to the global developer advocacy team to work on application services on all the different regions where Red Hat has operations. And initially, I was working on APIs mainly, REST APIs. When we acquired Treescale from the Red Hat perspective, and we started to get into the market of API management and APIs and such. We already have some projects and products regarding integration space, as well as other runtimes and other capabilities. But I joined mainly for helping out with the APIs. But then we also decide to go deeper into the event-driven architecture space. We already had our GMS broker coming from ActiveMQ when we were working with Fuse. However, a couple of years after that, we decided to also start working with Apache Kafka, and we start to get full into event-driven architecture and EDA and Kafka and so on. So I started to also take care of that angle from the developer perspective. How do I, as a developer, I care about Kafka, and how do I integrate with my applications? How do I develop for EDA? And one of the things that I noticed is that accessing a message broker or Kafka or WebSockets was very similar, but the tooling that we had for consuming those services, even for sharing the information of Fuse and topics, was not the best things. And this was coming from me when I was comparing what we used to have in the REST APIs with what we had in the broker side. In REST APIs, we have Open API, we have specifications, we have contracts, we have developer portals where we were exposing keys and being able to consume and having self-service management. In the broker side, it was still like, oh, you need to fill a form and then you will get a user, and this is the endpoint, and here's the 200 pages PDF file on how to consume from the queue, right? And there was like, come on, I mean, we have moved away from so long time ago. We don't need this anymore. So I joined the work from the Async API initiative and become an Async API ambassador. So doing a lot of work on bringing all these benefits from the API and REST API world into the event-driven APIs, everything that is related to asynchronous communication. So that's my background. And obviously, as a well-crafted Red Hatter, I'm an open source contributor to different projects, Camel, to Keycloak, to Microx, and others. And as a personal note, I do like history, travel, and I consider myself a food enthusiast, mainly from the street vendors, not like gourmands at Michelin stars, not really that. It's more like street food. So being here in this part of the world is actually pretty good. We can experience a lot of great things over here. Here's my Twitter handler. So if you want to continue the conversation or follow up us in what we publish, you can reach out there, or with their local team. They have our contact from the Red Hat perspective. You're already in contact with us. So yeah, that's me. Let's go to the meat of the session. So we will be talking about this concept that we call the event mesh, or the service network, or the virtual application network. It has different names because this is a concept and an idea that different vendors we are working on crafting this idea of an abstraction layer on top of application connectivity for application developers to make it easier to connect and consume services running on different clusters and in different clouds. This is because at the beginning, we were working with a single cluster. We thought that when one single mega cluster with, several number of nodes, and that will be their own private cloud. That was the idea when OpenShift was starting, version 2 and version 3. Later with version 4, we start to diverge into that space. And now what we're seeing from surveys around the world is that we have a world where customers and users have multiple clusters deployed in their organizations. And in some of those organizations, they are even deploying one Kubernetes cluster per application, or per business application, business domain, right? So that's a change in the way that we were handling connectivity. Because if you remember, one of the bases were to have connectivity between applications within a single OpenShift cluster is through the service discovery to the DNS, right? And we're able to then connect and have the software-defined network to be able to route to the different services and pods available in the cluster. That works great for one single cluster. But I'm telling you that now customers have multiple clusters. So what do we do then when you suddenly have an application that is running on its own Kubernetes cluster, and suddenly you need to go and connect and consume from an application that is running on a different cluster? Well, maybe if you're saying that both of them are running on Kubernetes, you can say, okay, I can use a Kubernetes-based solution to solve it. But what happens when you need to go beyond that and go all the way to your legacy applications, your legacy systems, your VMware or your bare metal, your mainframes. So there's where the concept of multi-cloud comes into play. And by multi-clouds, we really mean multiple sites or multiple clusters or deployments. So if you are working with edge computing, that's going to be considered a cloud or a site where you are deploying applications. If you are going with different multiple clouds, it's going to be something similar. And this is because there are different reasons why you will be ending with this kind of applications distributed across multiple deployments. Because of data gravity, where you still need to connect to the mainframe, you cannot put the mainframe on the cloud, or you're using a database that is licensed to hardware that is still running on your own data center. Or because you want to use capabilities from different SaaS offerings. Like, yeah, I'm using Salesforce, so I will connect to the Salesforce cloud. I won't be able to move Salesforce into my own AWS account and things like that. So there are different reasons. But the thing that we all acknowledge is that our applications will be spreading across multiple target deployment targets. So that's the one of the things that we will try to deal with Even Mesh. And obviously, when we're talking about multiple clouds, we're talking about multiple challenges. From silos, where, okay, I have my application running on one cluster, and if I need to communicate, I need to do an integration mesh for that, point-to-point, ETLs, or other more custom-made integrations. The problem is that also that triggers problems with integrity of the data, right? So if for some reason something fails or it's not updated with the latest fields, copying information from one cluster to another, it's complicated and it's prone to errors. So we want to avoid getting into those pitfalls. Because what we really expect when we are talking about hybrid and multi-cloud, it's first a couple of these things, right? So the first one is standardized environment where my infrastructure team as well as my developers have something consistent on the way to manage all those deployments. Because if you are in an organization that is using, I don't know, at least 2 cloud providers plus VMware, you will need to have a team specialized in all the different details on how to consume the native services of your cloud provider one, as well as the one on the on-premise data center. And that's complicated because it's easier if you have something like a baseline that then everyone can reuse or use. Obviously, scalability is one of the one of the features that you expect for this. No artificial boundaries for applications. So one of the challenges that we have when we are deploying an application that consists of an UI, a backend microservice, and a database, is that if we need to deploy them across these multiple locations, to consume one of those services, we need to go through an API gateway, or we need to be able to know exactly where is the reverse proxy that will be serving that web service or that microservice. And the problem is because we are getting out of one cluster and then getting into one cluster. If we don't have a network that expands across both of the clusters, then discoverability of those services becomes more complicated. So we want to avoid those kind of things. And obviously, the part of security and policies and compliance is something that needs to be available in any solution that covers this kind of aspects. So what we can do is first move from the traditional just REST HTTP connections, and then being able to embrace event-driven architecture. So one of the things that I tell everyone is that if you are dealing with somebody that says that you need to do only EDA or only HTTP, they're probably not looking at the whole picture. right? Most of the times you will need a combination of both protocols and both patterns to be able to communicate and connect your applications. And the important thing here with the concept of the mesh is that you want to decouple how you consume those events, how you consume those connections from the implementation details. So you want to have these loosely coupled microservices where you can decouple not only in technology, like microservice A that is running on Go with microservices B that is running on JavaScript or Java, but also being able to decouple on time, right? So if my service is not available, I can just wait and retry using things like service mesh, but also we can use a store and forward pattern to have the broker being able to deliver the message and being able to share the information with the interested parties in the future. So patterns like publish and subscribe, store and forward are aspects of the same connectivity requirements that fulfill and cover some of the challenges that we usually have in the connectivity side. So this is why these components are getting more relevance lately, because we got to a point where just using REST HTTP APIs was not enough, right? We had to come with things like service mesh and other solutions to try to overcome limitations on the protocol. The good thing is on the EDI side, we have a ton of protocols that incorporates a lot of these challenges already out of the box. So we can get the benefit of using reusing those as part of a complement for our architecture. And when we were talking about events, most of the times we're talking about changes in your system, right? So if you're storing a new customer or you are getting information of a new buy order, those are changes in your system, and those are triggering what we call events under the event-driven architecture term. However, most of the times what you see, it's not the change itself. You just get the notification that there was a change in your system. And most of the times that notification becomes a message that you receive as part of your system. So that's why most of the times you will get the concept of message and event and broker and event boss together, because they are different aspects of the same situation that is happening in your system. So now that we have now acknowledged that there's a notification that it's telling us that there has been a change in the system, and that's an event, those events can come from everywhere in your system. So if you are sending an email, that's an event. If you are storing a file into S3 buckets, that's another event that can be triggered. If you are running an Ansible playbook, that's another event that you can capture and such. So any part of your systems, any part of your architecture is generating some kind of event. The interesting thing here is, now that you're generating events, what do you do with them? How do you handle them? How do you really get value of them? Because today, I can tell you, most of your systems are generating those events. If you're running OpenShift, you see a lot of, moving logs into the dashboard. You can see a lot of information going on. And if you are administrators of a Kubernetes cluster, you can either ignore it, or you can plug in, some solutions to take actions based on that. It will depend on how much you care about events and what important is to you. And in the case of your systems, most of those events will be related to business-related, changes, right? As I was saying, a new customer, a new transaction, a delete customer, and or a cancel subscription. Those kind of things are mostly things that your business team will be interested in and get, capture, process, or even analyze. So the problem is if we have events being created in every single area of our architecture, how can we then uh, homologate those events and being able to create this concept of a tissue that allows us to capture those events and being able to propagate those events to the interested parties, right? Because an event that is not processed by the people expecting that, then it's not an event that we can get value from. So the concept is actually that the mesh is that connectivity tissue in between that gives you the value of being able to capture those events and being able to consume those events and being able to process them. So the concept of the mesh, it's this dynamic infrastructure capability. So we're not talking about SDKs nor applications. It needs to be pushed down into infrastructure capabilities to be able to have this baseline to connect applications across different clouds. So similar to what Kubernetes did for compute power, where we don't care about servers or VMs anymore, we just care about nodes and pods and volumes and services. The idea is to have these same building blocks to have an abstraction layer on top of the connectivity. So yeah, we still have to have that implementation the same way as we today have VMs and bare metal for our Kubernetes nodes. But the difference is that from the usage perspective, we don't care about those details. If you're running on an HP server or if you're running on an IBM P6E server, from the Kubernetes perspective, you just see a node, right, that has some limitations, some tainings, but still it's compute power. So in the case of this even mesh, what you will have is endpoints where you can connect and be able to get information for your services, or you can be able to push information to the mesh. Now, as we were saying, one of the important concepts that we have, for example, with Kubernetes and OpenShift, is that we all know what a pod is, what a service is, what a volume is, and every single volume from the PVC perspective is the same, right? Because we have a standard or a way to that we have agreed that how it behaves and how it be clear. Obviously, the implementation, like the ingress controllers or the storage classes, will vary and will be, specific of the implementation. But the way to request a PVC is exactly the same as the way you create an ingress. And so for the communication and the ADA perspective, we have something similar. And this is through cloud events. So cloud events, it's a sub-project also available at the CNCF Foundation that allows us to have this a standard wrapper for our events, for our communication, where we can get a specific set of metadata values that then we can use to identify the events, to know exactly when they were created, or what type of events are we consuming or we are producing. So we can have that information. Also, there's like a payload area where you can then put specific structure that is related to your business domains, right? So the idea is to have this standard type. Or obviously, there's some toolings to be able to read them, or write those events, and so on. Now, from the business perspective, how does it look when you are using the mesh? So again, we have our connectivity tissue, and we have a team that perhaps it's dealing with registrations. So they have an application where people sign up. So the team then can produce events and send them to the mesh every time there's a new user, that there's a new registration. The interesting thing here on the change on the way that we share information and data in the mesh is that instead of the mobile team thinking about who's going to receive the connection or who's going to receive the event, what they do is they just push into the mesh the event. So anyone that is interested in that kind of event, they will know that there's a event being generated of type user registered, and then being able to consume that. For example, the marketing team. The marketing team knows that there's an event that is available in the mesh, and they can start consuming that. Now, this event is being generated by the mobile team, but if there's tomorrow a new way to subscribe, perhaps through a third-party partner or through a different mechanism like a manual form, you can still consume that and being able to produce an event at a certain moment. And the marketing team does not need to ask these new producers to send them the events to them. And the same thing happens with other teams joining the mesh, right? They can produce other different type of events, like a payment was completed or a transaction was closed. And the interesting thing with events and event-driven architecture is that compared to the synchronous request response communication with HTTP, it's that you can obviously decouple in time and receive events that were generated in the past. So that means that if you have a lot of payments flowing in your mesh, perhaps tomorrow you are working with your intelligent application team, and they are doing some training of models, right? So AI ML models, and they want to know exactly how to detect potential frauds in your transactions. And this can be done getting connected to the mesh and being able to extract the events as they are happening from the payment systems. Some implementations for the mesh and the bus allows us to have the concept of replayable events. What replayable events means is that we can not only being able to receive events from the past, but also rerun those events as many times as we want. So if we have a lot of transactions during the end of the year, we can then read them and then do the processing, for example, training a model. And then we can say, okay, I want to do some changes in my variables and then rerun the exact same set of data in the same order that they happen and see how it changes from my prediction or from the way I'm processing it. And obviously, this requires that you are able to store your events and your data and flowing in the mesh for at least a certain amount of time so you can replay those. But this capability, it's not available with other types of communication. So the mesh allows us to do these kind of things. The other way to do around it, you need to store them in the data lake or another type of persistent store, and then just reprocess them artificially, not in the same flow that they were originally sent. So this is one of the things that allows you to evolve rapidly your applications. You can just tap into the source of the events, and you don't need to really be in sync with the source of your events to be able to consume that information. So this is an example more landed into the details of the implementation. So imagine that you have a database running on your on-premise data center, and it's running an Oracle database. So obviously you won't be taking that to the cloud. So you still want to get access to those events being generated by the database, perhaps implementing change data capture. It's a pattern to be able to listen to transaction logs from the database. And then that information, yes, it's useful in that database, but what I really want to do, it's either trigger a serverless function, because that system is not used that much anymore, but we still have valuable information on our legacy system. We want to share it, right? So we are going to be triggering a function that just gets executed when there's a change in this database. But at the same time, because it is still a transaction that is flowing into the business, we also need to send that to the data lake because it will be part of the numbers for our total revenue in this year. So we still want to do and have that information. But instead of changing the application to send the information directly to the data lake or having to implement an extra ETL just to take the information to the data lake, we can implement the mesh to be able to generate those events on almost real time. Both it's not that, but it's very close to the moment where it is happening, right? And the interesting thing here is that we currently have just 3 pieces working here. But if tomorrow I want just to add another cloud vendor or another data center, we can just tap into the mesh, connect to that, and automatically being able to route events to that new site. So that's one of the benefits that the mesh allows us to have, because we're again abstracting the implementation layer and the connectivity into a more high level configuration and architecture. Any questions until here?
But in this case, right, can I check? Your Oracle could be a VM. That means whether VM or microservices can go through the same service mesh, event mesh.
Yes, that's one of the things that we are going to be covering. So as we were saying at the beginning, so when your applications are running in a Kubernetes cluster, there are some Kubernetes-based solutions that allows you to have that. The concept of the event mesh goes beyond just one single implementation, because the idea of the mesh is to be able to connect not only Kubernetes clusters, but also any kind of solution up there. And we're going to go on that. So yes, OpenShift is the core and one of the central ways to implement the backbone. But we know that there's like in a parcel service, you can have this concept of the last mile, where you're extending your network to the outer faces of your transport network. So we have the exact same thing. OpenShift is the backbone, but we still need to connect to legacy applications like VMs or other vendors that are using still VMs on the cloud provider, or Lambda functions directly on the cloud vendor. So that's where we need to go beyond just the Kubernetes cluster and being able to extend the mesh all the way to those different sites. And we can do that with the technology that we have right now. So let's see how it works. There are different technologies that we have been covering right now. So we have MQP, that is kind of protocol. We also have implementation details for event-driven architecture like Kafka. But the cloud-native piece that we want to add is the Knative eventing part of the architecture. Basically, what we call in the OpenShift world the serverless capabilities of the platform. From the Kafka perspective, it's a distribution that we have as part of Red Hat. We have MQ streams that it's mostly being able to help you run Kafka on Kubernetes as smooth as possible, as GitOps friendly as possible, so you can focus on your applications and not managing Kafka itself. So that's why we created projects like Streamsy. It's also a sandbox project from the CNCF Foundation to be able to make the experience of running Kafka on Kubernetes as smooth as possible, providing our own container images, our own operators for Kafka, and then being able to build and complement your architecture with Kafka as easy as possible. And this is just a piece to implement Kafka, but we have more of those. As I was saying, OpenShift serverless, it's a set of capabilities on OpenShift that allows us to get certain features and possibilities. I don't know, who of you have been using serverless in the past? Any of you? A couple of you? Perfect. So actually, we're adding more capabilities to OpenShift serverless every time. So at the beginning, we start with Knative serving. That gives us the benefit to scale down to zero or scale our loads based on the amount of requests that we have, right? So we have the autoscalers that were based on metrics. Then how we have service pinit serving that allows us to increase our pods instances by requests all the way to zero. So you can remove the pod until there's a request, and then we can start the pod. We added functions. So if you have been working with the concept of serverless, there's two different ways to target serverless, right? One is deployment model, where you have zero pods running if you are not having load. And the other is the programming model that is basically focused on function as a service. It's basically the option to have just snippets of code and then being sending over them to the platform to be able to execute them without having to, compile and build the application and such. But the one that we're interested into is the Knative eventing part from OpenShift and Knative, where we are able to trigger our serving deployments, not only using HTTP requests, but also any kind of event that it's able to flow through the Knative components. So this is the part that will help us to have the building blocks that are creating the abstractions on top of brokers and on top of integrations with those brokers and the calls to our applications. So we're going to go a little bit on the details of Knative eventing. There are concepts like channels and subscriptions that tell us how to connect and plug to different streams of events that are flowing through the architecture. And those events, as I was saying, are coming from different sources, from databases, from SaaS applications, from other domains of your own systems. But the interesting thing here is that your target applications can just subscribe to these channels and being able to consume those events as they are happening. You can receive all the events like in a subscription to a specific channel, or you can use a way to filter those events based on the type, right? So depending on the content of the event, we will receive them, or we can discard those events. So the idea is that instead of having your application to know how to connect to a Kafka broker or a NAT service, you just need to consume the primitives on OpenShift for that. So it makes it easier to consume and deploy those applications. Now, the way to connect and the way to consume applications to the mesh is where we have the integration pieces. So as we were saying, there were different sources that are generating and consuming events. And from that perspective, it's pretty much open. So anyone that can either deploy a container on Kubernetes platform can consume the event, but also we have an option to implement these endpoints away from the Kubernetes platform and being able to consume them still. So we are able to have this connectivity tissue going across all the different technologies, .NET, JavaScript, Spring Boot, Quarkus applications, with Apache Camel, basically anything that it's available as part of the connectors. And going into the details of Camel, we have more than 300 connectors to allow us to capture events and connections to multiple sources and multiple targets, from Slack to Telegram to ServiceNow to Kinesis or even Hub or just an SQS. Camel, most of the times we'll have a connector that will help you avoid having to recreate the logic on how to connect to those services. And it's also available as a way to have a declarative approach for those integrations. So that means that you need to just declare a YAML file and tell, oh, I want to connect to this Slack channel, and this is where I want to send my information to a Kafka topic. So instead of having to code, you can just define a YAML file with the different flows that you want to execute, and you can wire them together so that Camel being able to deploy those integrations as applications or as containers running on Kubernetes. And this is done mainly with the operators. So remember the operators from OpenShift and in general from Kubernetes implement the operator pattern that allows us to have this declarative approach on the definition, right? I want to have this, so the operator sees what's the desired state and then executes all the different tasks required to be able to get to that state. In the case of Camel K and integrations with Camel, it's as easy as just define where is my YAML file, the structure of my YAML file, and then just run a CLI command, or we can just do OC apply to deploy the application as we are going to be looking at the demo. And then the operator will take that custom resource and being able to execute the deployment of that integration instance into OpenShift. So custom resource then becomes through the operator a deployment as OpenShift deployment, or even as a serverless deployment, where you have the possibility to go from 0 to n amount of instances of that pod running. This is interesting when you're talking about YAML files, because you can remove the requirement of coding, as well as you can get access to UI designers to create those flows. So there are a couple of options in the community to do these kind of integrations. One is Caravan, the other is Kaoto, and they allow you to craft that YAML file. So if you don't like YAML, you can use a graphical interface, or you can just craft your YAML. As you are OpenShift users, I will expect that you're very happy with YAML, so you are going to be using that directly, right? Oh, come on, bear with me. Now, the interesting part on change the capture, the one example that we were showing in the diagram, is that you need to connect to legacy applications. Some of the times you will have, these kind of applications, right? And if you have these kind of applications, you don't really want to mess up with them, right? You will want to modernize that without touching the code. So how can you do that? Well, Division is a way to modernize those kind of applications. So instead of going into the application and changing the code for, propagating the data to another system, you can use this pattern that has been available for a while, but it has gained more relevance lately, is that you can read from the transaction log of your database and then get all the commits that you have done into that database, and then generate events from those databases all the way to the event mesh. So Divisium, it's one of the projects that Red Hat sponsors that implemented some of the connectors for common databases. So it's basically a Kafka Connect connector that reads from the transaction log and then generates the events, package them as cloud events, and send them to Kafka. So make it easy to consume those events easily. And we have support for different databases, right? We have connectors for MySQL, for Postgres, for MongoDB, for SQL Server, DB2, Oracle, and so on. And because every one of them has different structures, that's why we have different connectors. But the important thing here is that the event that is being produced by any of those databases has the exact same structure and has the exact same wrapper that we were talking with the cloud event configuration. So that means that you can then get that event and check what type it is from the business perspective. And it doesn't matter if it was coming from one database or another, you will get most of the information coming into your application. So your communication or your connection between applications looks something like this, where you have a source on the left side that in the case of Divisium, it's going to be a database. But if you replace Divisium as the source and you put the camel in this side too, you can get access to all the different components as sources that is now sending information into our service network. If we're implementing that using Kafka or we're using any other technology, at the end, you can generate events for any of those sources and then send the information back to any other system available with the connections. Now, we are talking about Camel as a way to connect because, as I was mentioning before, it's offering you the possibility of using these custom resources and being able to deploy through the operator. But if you want to do that manually with a microservice, it's exactly the same thing. The only difference is that here you don't need to do any coding, any application development. It's just configuration through the flow. So that's what we find more appealing for this kind of infrastructure. Now, this is how it looks from the high-level perspective. You have different deployments, different clouds, and you're using either Knative or one of these direct protocols to be able to access the event mesh. As I was saying, one of the interesting parts is that we can offer to our users an abstraction layer using the Knative primitives that talk about brokers, that talk about triggers, but it doesn't go in the details on how do I connect to that broker? What is the implementation details of that broker? So I don't need to think from the application perspective on which specific client I'm going to be using and what happens if tomorrow they change it and so on. Now, the good thing is that even though we have those abstractions, we still have access to the implementation layer where we are getting all those messages being able to flow, and we can still be able to tap into that. So we can use the abstraction building blocks, or we can just tap directly into the protocol. So it's building on top of the current existing technology. Yeah.
What I from this diagram, maybe I'm wrong. From the AWS, I can put Kafka Knative in JWS, or if I'm working on AWS, I want to build an event mesh. AWS have its own service. Okay, they have their own event bridge. Apart from that, I can use these three products, or it's just example which you are projecting out here.
So it's you can say that it's an example, because at the end, I mean, AWS has its own Kafka distribution, right? They have a WK, or I don't recall exactly what is the name, MKS, Managed Kafka Service. So that's AWS. Azure has its own even hub. So that's why I was saying, like, Event Mesh is not a product that we sell. It's an idea, it's a concept that we will try to share with you about how you can use different pieces from the current ecosystem and being able to plug them together to create this connectivity tissue. Now, at the end, what you need is the implementation that it's able to put into the architecture those patterns, right? Store and forward, the publish subscribe. It could be through Kafka, it could be through other implementation like Red Panda or through NATS. In the case of Knative, they have abstractions on top of different implementations. So you can switch and change the one that you find more useful. That's why when we were talking about the diagram here, let me see, this,
Mhm.
you notice that each one of those are using the local event bus.
Yeah.
That local event bus should be leveraging the best of breed in that site, right? So perhaps in the in OpenShift will be a Kafka based on MQ streams, but perhaps in Azure you will be using even Hub for that, or depend on how you feel comfortable with that. The important thing is that there should be a connectivity between all of them, so you can then share the information in their own local environments. So it's basically doing a translation between all the different implementations. The important thing is because all of them have the same cloud event wrapper, they will be able to be consumed and read by any application there.
Okay.
Yeah, okay, perfect. Yeah, if you have any other questions, please just let me know.
Next question is, how do you set up this? Because we're back to the old question, right? You have on-premise, whereas you're talking to cloud. This is the actual multi-cloud environment which you're talking about. To set a layer on top of that will be or how OpenShift do provide the provision where they can be bridged together so that it become easier. Because if you see on the perspective of implementation approach, it's a complex approach. You have one producer, two consumer out there, and the consumer are in two different environment, and the producer is on the third environment. Okay, how to set up the communication out there? Does OpenShift provide a platform out there where you don't have to worry how exactly communication have to be there? You just bridge it, you just set up and configure out there, and internally OpenShift will make sure the network communication will be happening out there.
So you have different ways to tackle this, because at the end it's an implementation decision. If you're using Kubernetes clusters, you can implement that using tooling like Submariner or like federated service mesh that allows you to do connectivity between different clusters. But that only solves the cluster part. However, there are other service mesh distributions that allow you to run the sidecars as processes in a VM or a RHEL machine, a Linux machine. That's the proposal that things like Kuma does, or like Solo Blue Edge does. And this is actually one of the proposals that we are bringing with projects like a Scopper that allows us to run these processes as Linux services or as Podman containers that then implement the connectivity between the VM or the Linux machine and the Kubernetes service in a way that we can expose the services running on Kubernetes as a host name and a port in your VM.
Okay.
And the other way around, you can expose VM services running on your data center on premise as Kubernetes services in your Kubernetes cluster. So that's where we close the gap between Kubernetes environments and non-Kubernetes environments.
Okay.
So in a way that you are able to get this type of connection, right?
Yes.
Yes, OpenShift and the connectivity in orange in this diagram can be achieved using Submariner. And again, it's the exact same thing as we were saying. We were looking at the diagram before, where you have a local bus. In the case of OpenShift, you can have communication through Submariner or through the federated Maestra. That is our Istio distribution. But when you are going out to other public clouds where you cannot deploy the same Submariner, or where you're going to virtual machines, or where you're going all the way to Edge, where you're running Podman on a NUC, that's where you get these routers, as we call, that are based on, in our proposal, through Scopper, but also through, if you're implementing using Kuma, they have their own solution as well. If you are using Solo IO, they have their own proxies or routers or stops that are implementing the same pattern. As I was saying again, the idea is that event mesh is a pattern that you can implement using different technologies. In the demo that we're going to be looking today, it's going to be focusing on mostly Red Hat technologies, but there are other options in the solution. So let's talk about the demo. So what we are going to see today, it's this concept of actually the integration between legacy apps and the event mesh. Unfortunately, it's going to be running on an OpenShift cluster, but you will get the idea. Where we have a database producing events, we change the capture, and we will put everything on a local bus with Kafka. And then Troy will help us with the way on how to consume using the primitives from Knative for that. Yeah, let's get into the demo. Any question before we start the demo, or you want to see it running and then get all your questions answered? Okay, so let's go to our application, right? So we have this legacy application. We don't want to change the code. So what do? Well, we bring Debezium to generate events and then consume through Kafka, right? So let's go to the topology where I have my application. So I have my application running. It's storing all the information in the database that is running Microsoft SQL Server, a very old version actually, like 16 something. And then we want to capture those events using Debezium and sending those to our Kafka StreamC distribution. And after that, what we want to do is we want to then use Camel, as we were looking at, to be able to send those events to something more friendly, like an Elasticsearch, or something cheaper, like a Postgres database. So we can have a replication of data to both of these services. So we have seen the application, and let's go now and see the Elasticsearch, that is the HTTP endpoint. So let's go to Elasticsearch. And we have already a index here, that is the orders. And let's see if there are some entities in the index. Let's make it nice and clean. So it says that yeah, when we do a search on the index, we found that there are 3,015 entries. So I think we can say okay, I don't recall but we can search for different flavors or different item names like lime and such. But you get the idea. There's 3,000 records currently in this index. So as we get back to the application, we are going to be loading a ton of orders through a CSV file, right? So because this is an old application, we were still receiving a file with all the different orders. So we are going to be loading that file into our system. So we just click on load file, and it reads the file and then just stores, 1,000 number of orders into the system. So what is going behind the scenes is that Debezium is reading that commit that I did from my application into the database, sending each one of those records as or rows in the table as individual events into Kafka, and then we are able to use the Debezium connector, the Camel connector, to be able to send that information. And we can see that from here, because as I was saying, the good thing about this is that most of these solutions are based on a declarative approach. From Kafka, that it's a custom resource that has the YAML file to define how many ports and how many nodes are we going to be using, all the way to the connector that tells me, like, like the division connector that is just configuration. So again, it's a YAML file with the configuration where I'm saying, oh, you're going to be reading from the Microsoft SQL Server. You're going to be reading from this database, and just here's the connectivity configuration. And then on the other side, we have the Elasticsearch connector that is telling Kafka to read from my cluster, and then being able to send information to my Elasticsearch endpoint to a specific index, and then just say, okay, read from this topic, and then just store the information on Elasticsearch. So let's see if this works. So remember, we used to have 3,000 records. We add 1,000 more, we should have 4,000 records, right? Let's do a refresh. And yeah, we have now 4,000 records in my index. So this is a way to get application modernization. You can also use this to share information within microservices. You can use this for implementing a strangle pattern where you start to move your services to independent databases. So decomposing the monolith, so you are start to spread your applications across. Now, the interesting thing here is that we are seeing a lot of details here, a lot of implementation details. We're looking at the Kafka, we're looking at the connectors, we're looking at the Visium, we're looking at the Camel connectors. But the idea is that we have these notions of broker and sources that will then trigger our applications. So we can do something similar to this and get the primitives from Knative, from a broker to a Kafka source to my sync application. So I'm going to be running this. It's the Sockeye event viewer that will just receive and send the events that are looking at. I'm just going to remove this broker for a moment, and I'm just going to connect directly to, oh my God, it's not. Okay, this is a live demo, so that's why sometimes it crashes. We did this manually. We just copy the information one here. Yeah. Okay, now this should work. Yeah, we got the connection from our source into a broker and then the Sockeye. So let's see if this works. So again, we are gonna be loading an order. And this time just one, so we can just see one record. And then just load it. And if everything works, we should see the event happening here in a moment. And yeah, we have the event here. So this is just a simple application to view cloud events. But the interesting part is that this could be your application that then takes that record that it's happening and it's doing any kind of processing, right? And as you can see here, the details are using the wrapper from the cloud event with certain properties and certain values of the wrapper, so you can take action. So you can do filters with the triggers. You can say, oh, I only want to hear about the topics coming from orders, or the topic coming, sorry, or the events coming from the type customer, and so on. So this is an example on how to use this abstraction on top of that. Now, Troy is going to be showing us more details on how to use these building blocks for more complex scenarios and more evolving architectures.
Okay. Before I start, just short introductions, right? So, my name is Troy. So I'm one of the SA here, so solution architect. So yeah, I've been based in Singapore, so I'm handling mostly a public sector company accounts. Yeah. Okay. So what I'm going to show today, I think just now Hugo already mentions, right, that now that your legacy applications that typically you don't want to touch, you can even expose the data using the data capture method. You can get the data out, all the event, and then you can have the event in Kafka bus, right? So now what you want to do, right, to make the events even easily consumable by other services, you want to hook it up to the event mesh, right? So this is what I'm going to do. We'll show you the event mesh construct itself, and yeah, with the demo, right? And from there, I will have different kind of services from the record splitter, some record processors. This is a very simple record processing use cases, right? A best processing use cases. There is a splitter that will split the record into multiple records, right? And then there is a processors, and there is a sending notifications as well, and all hook up into the event mesh, right? Okay, so I'm going to go to my topology now. So here, actually, you can see that if you're wondering, right, what is the event mesh construct, I think it's already mentioned. Event mesh basically, I think the key enabler is the K-native eventing. Right? In K-native eventing, essentially, the key thing is this, right? Either channel or broker, right? What this does is actually is the one that collecting all those event coming from multiple different sources. So it will aggregate all the event from a lot of different sources and then distribute them, right? That's the key thing, right? And they doing that using the same cloud event construct, which is the same protocol. So you're not dealing with the proprietary protocol like AMQP. Something is like Kafka is also, they have their own protocol, so on and so forth, right? Some of them use REST API, FTP, so on and so forth. So the way what we want is to have so that the event itself easily accessible by developers, by other application, is to have this standard protocol. And that's what the K-native eventing allows you to do, right? So first of all, I will need to define the event itself. So here I have a record to receive, right? So I have a channel here, and then I will specify which event sources that I want to collect and put in this event mesh. It is the channel is the record receive event, right? In this case, I have I want to collect from, this is basically from AMQP, messaging the CMS systems. I also want to have, even REST API is also considered an event, right? So the event is basically someone give me a request. So I have another REST API for client to upload a document or files, right? And then from there, then there will be processing. Here is a record splitter. There will be a processor record. And then from there, I will have another record queue event, right? Because I will split the batch process to multiple individual records and then put it in a different queue, right? And this different queue again can collect the record from multiple sources. One sources, of course, from this record splitter services,
another sources, I just want to relate back to your, let's say just now the legacy data, right? Data that farm into Kafka. So you can put the Kafka sources and then put it back there as well. So it's again collect, but it's just a different event, right? And then from this queue, it will be consumed by the record processor that will process the record. In this case, it's very simple. I just put the things into put the records to the database. Okay. And then once I finish processing, I will again put the different event, right? Record process event. And then from there, I will just send a notification through Slack, right? Send the record to Slack channel, right? So yes, that's basically the flow. And as you can see here, all this actually all these services are actually a serverless services. So here you can see that there is a Knative service. This is all our serverless services. Actually, I built this using Camel K. I will go through that into more detail a bit later, right? So the good thing about this is that if I click here, you can see that it's all revisions are auto scale to 0. Means there is nothing actually running as of now, right? Means it doesn't really consume any resources. It's really 0, right? Here is also 0. 0, right? And okay, so this one is Workspace DB. Of course, you always need to have it running, but the rest of the thing is all 0. Right? Okay. So now what I'm going to do is I will just go to my MQ broker, right? So this is my MQ. I want to send some message to my queue, and then of course, what my expectation is after I send the queue, it will collected by my event mesh, because I just want to hook it to event mesh, right? And then the flow will, my application all will run, right? So in this demo, I will send in 2 records. It's very simple. It's just passengers data, name, nationality, flight number, passport number. Yeah, there are 2 records here. I use JSON. Of course, it's up to you what kind of format you want, but for simplicity's sake, I will just use JSON here. So I just put this string, put it here. Once I click the send message, I go back to my topology. Where is it? Yeah, you can see that. Yeah, this is now running. If you active, and then once this process, this is active. Put the database, and then the notification goes, right? And that's done automatically, right? Without, so once it's received, is once the serverless services receive some record that they need to process, it automatically spin out a pod. So now if I click here, I have the pod here. If I go to the Slack, yeah, I receive all these two records in my Slack, right? Okay, yeah, this one is just an animation, but if I take a look at this this pod as well, this booklet, now I have 1 pod is running, right? So of course, that's the benefit of serverless, right? It's auto scale. You can auto scale to 0. Of course, it's auto scale, so 0 will be a lot more makes sense for a test process, because test process doesn't happen all the time, because it will take a bit of time for all the pod to up and running, right? Especially if using Spring Boot, sometimes can take 10 seconds. But the good thing is in here we use a Quarkus, so the booting time, as you can see, is very fast. Actually, is around 1 second, right? Or even can be less. But if you running a REST API as yeah, you can see that now, because after 30 seconds there is no new message, it will just scale back to 0.
The one is REST API. All the circle thing is REST API.
Yes. It's a camel. It's a
So it's a pull or it's a push?
is a push. Okay. So, okay, yeah. Where were we? Okay, so now it's all scaled down back, right? Okay, the next thing is what I want to show is okay, so yeah, that's basically my first scenario. Another benefit that we can get from this kind of architecture is that I mean change request is always happening, right? You always have a new requirements, new things that you need to code, right? So let's say because just now I have two passengers, right? I want to maybe there's a new requirement. Say if I'm a Singaporean, if the passenger is a Singaporean, then I will need to check the connect to a certain API to check whether they are vaccinated or not. We need to know their vaccination status. That's a new requirement, right? And how you do that? Of course, naturally you want to modify your code, right? But is that a good way? I mean, the first principle of a good coding is like close for modification, open for extensions, right? Why? Because if it doesn't modify anything, you don't need to retest the existing code. It will just work, right? But you extend it, right? So it's make things fast. Because if you modify the current system, then you will need to retest everything. If the current system have 5 functions, you need to retest everything because you will break things, right? If you modify things. That's also why the reason why people moving from monolithic to microservice architecture, right? To make things smaller so that if at least if you break things, it's only small part of it. So that's the key of getting the agility to get your system rapidly evolving, right? So in this case, what I will need to do is because I will have a new logic, right? What I will do, I will just okay. This logic maybe I can implement it after the record is processed. I will call the API instead of directly go to Slack, only for Singaporean. So means I will need the two service that listening to this record process. One is for non-Singaporean and another one for Singaporean. Yes, they have two different logic, right? So here, because I have this kind of data, I don't have to modify anything else, everything else. I can just create a new service, listening to the same process, and done with it, right? So what I will do is, again, I just show you, I think here is where I will show you a bit of code, okay? This is just basically the power of a camel cake, right? I think it's a bit too small. Let's see. Anyone know how to? Is it okay? Command plus. Yeah. Okay. Okay, that's better. Yeah. So camel cave, I can specify my integrations. In this case, what I want to do is listen to the event from the record process and then call a certain API to get the vaccination records and then send it to Slack, right? So I can do this without any coding. I can just specify what the steps, the source. First of all, I need to specify the source. The source basically a blocker called record process. This is the source. So this is basically just reference component. So Camel, you have all these different components that you can use. What you need to do is just specify the component and then put some properties. In this case, in the property, I put a type called Singaporean. So I just want to listen to this blocker for Singaporean type, right? And then once I do that, what I want to do is I want to call an API. But in this case, I don't call an API. I basically just add some data there, which is I add the vaccination status, right? And then the next thing, I want to send the data to Slack. This is this thing. Basically, I use Slack component, I specify component, and it put two property. There is no coding required. Right? Very simple to understand. And this is basically all in a CRD. I don't need to build. I don't need to build the images. I don't need to do anything else, right? And then, of course, the second one is because I don't have to call the API. Still the same. I listen to the record process, and the type is other. It's basically other than Singaporean. And then for the Slack itself, the same. I just put this is a Slack component, and this is the channel and webhook URL. Now, this is already CRD. As I said, you don't have to code. It's similar like the Lambda. You just code and then push your code to upload your code to the Lambda. Everything will be generated for you, right? And then your system is up and running. So here, what I do, because this is already a CRD, I will just OC apply minf. This is a standard Kubernetes YAML file. Alternate scenario to YAML, right? Okay, now created the. Okay, you can see immediately a new service spin up. This is a call Singaporean service. Another one is just normal notification service. So now both services up and running. Right. Next, course I want to test. In this case, I will just use the REST API. Okay, just now in the first scenario, I used the Qubit for, AMQ. Now I will just call the REST API, right? Of course, here is one is American, another one is Singaporean, right? Okay, just use this API. Okay, then I press enter. Go back to the topology. You can see that now this is starts running. That's completed. This one is running. One's running, and then the notification should run. Right? Yeah. You can see that the container is creating. This is also running. Okay, so if I go here, you can see that one is without the vaccination record, the other one is with vaccination record. So, then I don't actually, I want to change the code, but I don't actually change the existing code. I leave it. You don't need to test. I just need to add, right? So this is how you actually can really speed up your development process. Do you have any requirement, any changes? Want to add more logic, add more services? You can just find the event that you need, hook it there, and then add additional processing that you need. Right? Okay, another one maybe that I just want to show a bit of this one. I think just now Hugo mentioned about Caravan, right? So this is a visual code, right? So I already installed a Caravan. This one. Like this. Yeah, it's too. So what I do is this is basically Caravan plugin. Right? I can just install the plugin in Visual Code. I can just create the integrations, new integrations. Okay. So I can just create a route. Okay, here I can see all the components that I want. So I can say no need to code. Everything is UI based. So you can choose the component that you need. For example, maybe you want to get from AWS SQS source. Of course, you can put your properties here, fill in your properties, right? And then plus you can do maybe filter, or you want to do, you can do a lot of different things, right? This is all the EIB integrations, right? And the component as well. Okay, and what it does is at the end of the day, it will create the YAML file that you see just now, right? From YAML file, then after that, what you need to do, just push the thing to OpenShift, and all the build, everything will be created for you. So this way, actually, Camel K really helps you to create a lot of integration very quickly. Right. Okay. Any questions? I think that's where we conclude my demo.
Thank you, Troy. Any question for Troy? Well, I'm just gonna show you the latest part because you were asking about the connectivity from non-Kubernetes clusters, right? Not Kubernetes sites. So I want to show you how it looks from the concept of the service network. Got it. So now we have more than one cloud. So I was showing you my cluster here, right? Remember we were doing the database and things like that. If you notice the URL, this is running on our sandbox, running on opentlc.com. So this is a cluster running on AWS. But I also have a service running on Azure. So this URL, it's running on Azure opentlc.com. It's also an OpenShift cluster, and I have connected them using our solution based on Scopper community project. So Scopper allows us to create this service network to interconnect applications across the layer 7 of connectivity, right? So I have this service called Scopper, and I have running on my Azure, we have this namespace. And if you see the workloads, there's nothing running, right? But my Scopper infrastructure. So with this Scopper infrastructure running, we can access our console. And we have a common site that is my AWS account. And I have my Azure in cloud being connected to my AWS cloud. And I also have my Mac connected to the service through the same AWS. And what I will try to do is I will try to create a route in Azure to be able to connect through AWS to my Mac machine and see if I can access my Mac representing the on-premise data center for an application. So in my on my local laptop, I'm running a container. So it's just a Podman container, or in this case, a Docker desktop container that is part of this Copper gateway that allows us to have the init of this configuration where I'm exposing my local service running on my laptop all the way to the internet. So here I have a service running on my port 8080. Or I used to have one. Let me restart it. So I have just a camel. So I'm gonna show it this very easy. So I'm gonna just create a new folder called Meetup, and then can you see this? Let me make it a little bigger. So I have an application here, and I'm just going to create an application. So the integration part, it's very interesting because if you see here, see the Meetup, I don't have anything here, right? So you see there's nothing. So I will use the Camel CLI. So Troy showed you how to use it, how to create a service using the UI, right? But I'm going to show you the power of project-less integrations. So Camel init, hello.js. So I will use JavaScript because that's the one that I have out of hand, but you can use the designer to create YAML and such. So I just create this application. So now the only thing that I have here, it's a hello file, right, in my folder. And this is built with some boilerplate, but I'm just gonna replace that with my code that it's using some JavaScript If you're JavaScript savvy, you can see what I'm doing here. But it's basically, I'm just going to create a REST service that will be listening on the endpoint say hello, and I'm just going to reply with a fake name from the faker module, and I'm just going to send that as a camel service. The interesting thing here is if you see in the project, there's no package config, no JSON config, no POM XML, nothing related to that. Just here my dependency to the file that actually needs to be twice. Let's see if this works. And for run, it's just camel run hello GS, and I can do development mode just to tail and see a live reload from my application. Let's see if this works. I start to run my application, and automatically Camel knows that there's a dependency for the HTTP platform to create a service, and then just run and expose the endpoint. Let's see if this works again. So port 8080, say hello, and now my service is running based on a GS file, no project related, but Camel can give me an application. So this is the power of Camel, power of Camelless. And just, Camel run starts the integration. So the same thing that you can get with the operator, but this is running locally on my machine, on a Mac. So the thing is that I want to expose this service from remote service. So let's go to Scopper CLI. And let's see Scopper service status. We don't have any service exposed, so let's do a Scopper service create. And let's create our service. So let's create a local host. So we are going to create a service for Scopper to expose my local host 8080. And mapping to HTTP. Let's see if this works. Okay, it looks like it's created. Let's go back to the platform and let's see if we see our service being created. So let's go to my service, and you see now that we have a new service being created in my Azure cluster that it's pointing to the localhost Java. But still, we don't have any pod here, but just the Scopper. So if we are able to access that from remote, it's going to be accessing my application. Let's create a route on my Azure network. And let's create an app that it's called my Camel. And that is going to be accessing that localhost Java service that I was exposed as a Kubernetes service that it's accessible. I'm going to target port 8080, and I'm just going to create that route. So if everything works, if I click on this link, I should be looking at how from Azure I'm connecting to AWS, connecting to my laptop, and getting a fake name. So fingers crossed. Results not found. Oh my God, didn't work. Let's see if we can fix it. So let's see the network components.
You need to say hello.
Oh, right. Yeah. Please let that be the problem. Let's go again. Say hello. I hate bats. Oh, yeah, it worked now. So here we have my service connecting from Azure to AWS to my local machine, and we are able to access and run this. Now, because we are having the load machine, we can say, okay, let's change this and say instead of hello, hello Meetup, And then I'm saving this, and automatically it's reloading and doesn't like the Meetup. So let's see again. It reloads. You see the log automatically reloading. And let's see if this changes. So let's do a refresh here. And here's hello Meetup. So this is the way how we extend the event mesh beyond just Kubernetes clusters. So here it's a Podman running on a machine, but it can be a Docker container or a service running on Linux on your own data center or DMC zone and being able to access your database. So instead of being an HTTP application, it could be your database. So instead of having the database, the SQL Server database in OpenShift, you can just keep it on your data center on-prem, and you're still being able to access everything like that. And you can see that there's other systems available, other sites, and everything is connected. So I'm not connecting from Azure to my laptop or from my laptop to Azure. I'm just bridging the connection through the AWS account. So yeah, this is the service network. This is the event mesh. This is the kind of thing that you can build with OpenShift and Red Hat technologies currently with the solutions that we are offering. So any questions? If not, I think we ran out of time. So we really appreciate that you are being here, and we can just close.
Yeah. Thank you everyone for coming. Thank you.
等一下，我把那个天幕，没有，等一下我